I joined Globant. Thank you for the recording. So this is clean and maintainable code. I joined the company like 4 months ago. Still very new to Globant, but not new to development. Have been doing this for 35 years. So the idea is that first we're going to go through some concepts in a practical way, and then of course going through some details and some examples of even just recent code, actual code that I use. Is not like confidentiality issues or anything. It can be shared easily because it's just 4 or 5 lines, just used as an example. And all of them became actual PRs that were joined, or pull requests that were joined into the main branch. So that's what I wanted. You always see in books this nice little example about the small classes, you know, class A, class B, and then they do the refactor or wherever. And then you go and see your own code or the code that you have left. They left for you, and it's like, this doesn't look anything like the code on the book. How can I start? So that's the reason I wanted to use actual code. So the topics we will be discussing is, well, what is refactoring, when it's usually needed, where are the refactoring obstacles, what is a code smell? Sometimes it's mentioned many times, and it's like, sometimes you don't have a clear definition of what is that. How do we detect refactor opportunities? Again, I just mentioned some ideas, but the idea is that you eventually become very good at doing this for your own code, and depending on the goals of your code. What I mean is that sometimes people rather have the logic centralized in a web service. Sometimes they rather have centralized in the database. You know, there are different approaches to that. So I also talk about how this needs to be a team agreement more than this is the way I like it. Code reviews should never be about this is the way I like it. It should be about being able to mention why did you use that, what pattern are you following, what good practice are you following. Well, we're going to show some examples of some refactors from real code. From that, I'm going to just mention the steps. It's going to become obvious as we do more and more exercises, let's call it. If you want to join doing the exercises, it's fine. If you want to ask in the chat, it's fine. Since we're not so that many people, you want to raise your hand and have an audio call, an audio question is fine. And then what I call advices and conclusions. Sorry. Oops. Okay. 1 second. Okay. Like I mentioned, I will be sharing concepts and experiences, tactics, approaches that I have found useful. It's not a comprehensive list. If you look up this topic in the internet, like many other topics, you will find there is plenty of materials in there. So going through all of them is not possible in 1 hour, especially with a practice. If it's just concepts, probably. Again, common patterns will be shown, but no magic or magic recipes exist. Like I just mentioned, if you want to be collaborative about, you know, expressing your point of view, expressing other options to do the refactor, is fine, because there are many different ways of doing stuff. When we did this the other day, some people say like, hey, well, why don't you mention extension methods? And say, hey, that's an idea. I didn't think about it. Probably reads better than the example that I provided. This is something that I hope it doesn't make you run away from this topic in the future, or even now. Trying to keep clean code requires effort every day, but it eventually avoids bigger issues, as we will see. And well, since this is a long topic, don't expect to get good in the first attempt. Like, I don't know, if this is the first time you're reading about it, getting knowledge about this or whatever. In general, this applies, I believe, to many of the topics in software development. So let's get into it. So what is refactoring and when is it needed? Pretty much refactoring is changing or restructuring existing code that already works without changing its behavior. And that's probably sometimes also the reason many, let's say, team leads or people higher in the hierarchy, you sometimes don't like refactors because it's like, hey, it's already working. Why are you changing it? We will get into that a little bit later. But usually cleaning the code or refactoring the code usually happens when you need to enhance performance, you need to improve scalability, you need to improve security or add security if it wasn't added from the beginning. And mainly, at least for me, maintainability is one of the really important approach. All of them are, but for me, it's like the one that I usually talk about. What I call a reality check is like from that four things that I just mentioned: performance, scalability, security, and maintainability. What is usually the reality of this? Like performance is usually just change when the client reports something is slow. I hope it's not the case in your project, but if it is, don't get desperate because that happens. Because trying to, let's call it, sell to to your lead, to your boss, to your colleagues that you just need to change some implementation because it's not fast enough, but the client has not reported anything, it's kind of hard. So most about code refactoring and all this is regarding that, how to find a way to approach it, to mention this to your colleagues so that it becomes important and that it becomes a standard practice. And of course, like I mentioned a little bit later, code reviews is the best place where you should do your, hey, this should be a function, this should be a method kind of comments. Scalability should be considered from the beginning. Trying to add scalability after the code basics is usually just moves the bottleneck to other part of the system. I think that's pretty clear what it says in there, but considering nowadays, most of the projects use some kind of cloud. And well, even though the cloud is flexible, making those changes can be hard if they were not considered from the beginning. I don't know, besides load balancing, vertical scaling, horizontal scaling, whatever. And sometimes making those changes also breaks stuff. So it should be better to include them from the beginning. Doesn't mean that they cannot be done in a refactor. We will not be covering these three that I'm currently mentioning. I will be mainly focusing on maintainability, but the concepts, you can apply them to pretty much security, even enhanced performance, scalability. It's more of an architectural decision and point of view. Well, adding security features afterwards, similar to scalability, is a lot of work and probably leaves other parts exposed, very similar to scalability, like just fixing one controller or just protecting yourself from SQL injection and forgetting about the other cases is not a good idea. But again, this is not the focus on this talk. I just want to mention, well, like it says above, security features need to be done eventually. So even if it's hard or these obstacles, we have to go through them. This is the one that I have only been in a couple of projects where this became true. What I mean is that for many months, if not years, the whole team didn't really care about keeping the code clean. And by the time it got kind of unmaintainable, it was already too late. You will see what I mean unmaintainable in a few examples or ideas that I hope you haven't come across. Where are the usual obstacles? Like you sometimes see a piece of code and you say, I will probably want to change this, but I don't want to break anything. I don't know where to start. I don't see the benefit. there is no task in my project called refactor this, please. Sometimes this happens. The leader is not willing to approve refactor. It doesn't have to be, you directly, just anyone above. So how do we solve each one of these, or how do we try to approach this? If you're afraid of trying not to break anything, using unit testing can help you for existing implementation. That's like the ideal scenario. If you're not going to do that, well, at least try to do enough tests, like let's call it developer tests, either if they are manually, whatever, but make sure you cover all scenarios. If you're going to do that, you might as well do the unit testing. I think it takes even less time than the other one, and you can just rerun it. That's for a different talk. Don't know where to start? Well, this talk is a good place to start, but of course, let's go to the guys that started this. And to be honest, I only mentioned here Uncle Bob, because I have learned this, let's say, more through experience. But I will share with you, and this presentation will be shared with you with some references. I even found like a list of 18 books about clean codes for you to choose. Uncle Bob is a huge reference for this. So how about, I don't see the benefit. So right in front, we have code that is not improved will eventually become technical debt. We always say, well, we will fix that. We'll fix that. We'll fix that. We'll fix that one day. This starts to stack and become higher and higher. And then it's going to be an issue, because that's where you reach this point where you change something. It shouldn't break anything, but it's breaking something else. And then you don't understand why. So that's the reason we want to keep the code clean. The high benefit is lower technical debt, more maintainable code. So if taking a change today will take you 1 hour, hopefully in the future, a similar change should take you hopefully the same. If it's not, if it's going to take you 3 times as before, you probably need to do some changes, because adding to existing logic might be as simple as finding the correct line and just put it in there, cross your fingers. If all of us start doing that, then when it does things breaks, who is going to maintain it? Like, it has become a patch of adding just if, and then it's completely unreadable. Especially with time, you start spending more time reading code than writing code, because there are less feature requests, and it's more about fixing bugs, for instance. So with legacy projects, or even projects which are as small as 6 months, 1 year, reading code takes more of your time than writing it. So let's try to make the reading part easy for us and everyone in the team. Okay, this one is like a custom or personal tactic that I found is, since refactoring is not a task in my project, well, try to, if you find something to do better, do that a small refactor that is related to your current task. I don't know, if you're changing a SQL query and you can make it more readable. Even formatting SQL files could be considered a refactor, because it can help you understand it better. And you can apply that to anything else. If you're changing a controller, if you're changing a repository, well, whatever, a website, UI, keep it clean pretty much, and try to refactor something that is related to it, not because you have to refactor. You first find the opportunity to refactor it, and then you decide to do it. Also validate that with your boss, with your team. Well, I pretty much went over this one already. Explain to your leader that if the code gets harder to maintain with each task if we don't do these improvements over time. And it will be an issue when it's too late to fix it. This is something that I just thought about an example. Sometimes many times we depend on frameworks. And I don't know, let's say we get used to calling certain method. Try to imagine something different than to a string, let's say, but that's not a bad example. Let's say all of a sudden a certain .NET version deprecates that. It's never going to happen, but then, well, we have to change that everywhere, right? But if the things that depend on frameworks, at least on the ones that are like very external and hard to make sure what's going to happen with them, if we encapsulate them into a function or method, whatever, we can just change it in one place. So keeping, like, if you want to move from version 4 of our framework to version 5, and it's kind of like just some names changed, yes, you can do a whole search replace in the whole project. I wish you luck with that, because the reality is that sometimes that string is found somewhere else, and then problems in paradise. So when there are code smells in many places, it becomes harder to maintain. It's like you start reading something, it's like, what? And then you read something below and it's like, what? So you don't want to read code like that, and you want to maintain it. So it's our responsibility as a team to keep it in a good shape. Like I mentioned before, this content is not like, hey, Mauricio only talk about, I don't know, 5 code smells or whatever. There are only 5. No, there are plenty of them. I could say there are as many code smells as possible ways of making everything run. And some of them have nice, clear names. Again, they're sharing the references. Other ones, like the ones I mentioned here, I just decided to give them some kind of name to them. So I have mentioned what is, code smells many times, but what is it? So, okay. Before reaching the actual definition, like this is the typical examples you find of that you are reading a code smell, or you're working on something that probably has a code smell. Like the one I mentioned, I made a small change and it breaks in many other places that are not expected. This one I had been there so many times. Like it took me at least 3 hours to understand this method. It's like, and you're probably tempted of adding a whole comment section about what you learned. This one is a pretty clear one. It feels like I'm doing the same thing over and over and over. It should be a better way to do this. It seems to be that there is a pattern here, but I'm not able to find it. That's the kind of feeling that is kind of important in there. This is the one that I was talking about just a few seconds ago. Sometimes you find, I don't know, let's say 10 lines of code, but before that you find 20 lines of comments. I'm just exaggerating, but it happens. Sometimes you're like, this method should be blah 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 blah. You read all that, is like, I guess the guy who wrote this didn't feel like making sure the names of the methods were readable, and the code should be as clear as the comments. And even some people consider any kind of comments that is not being used for technical documentation is a code smell. Like, why do you need that comment? Maybe the line below it is not clear enough in syntax in how it's read. So that's actually also another good guide. But there is many other ways to detect code smells. Code smells, as you have probably guessed, are not necessarily bugs or errors. It means the code works. It provides the expected output. But they are absolute violations of the fundamentals of developing software. It means that you can take that, show it to a colleague. I have done that so many times. And just ask them, what is wrong with this? And what is fun is that sometimes they find even more stuff than I, or other stuff that I didn't realize. And then you share yours and you go like, whoa, wow, who did that? You're like, no, it doesn't matter who did that. We need to just find a way to approve it, find to improve it. Don't play the blame game. The blame game is just for pointing fingers, doesn't get things solved. So just find a way to make it better. This is something that I found from Martin Fowler. He has quite some few nice books. Any fool can write code that a computer can understand. Good programmers can write code that every human can understand. Okay, how to detect refactor opportunities. So how? By using code smells. The one that I mentioned before, and some of the examples are here, and some of the many examples you will find online. There are lists with, prettier names than these. Like, they kind of make you curious when, similar to a news headline. You want to click on it and read about it. This is the first one that I learned about from Uncle Bobby's, like methods that receive Boolean parameters. We're probably so used to this that the first time we read this is like, why is it wrong? Like, everybody does it. We will see why. Or, how can it be done better? It doesn't necessarily mean that it's directly bad, because code smells is just that, things that can be improved. Multiple similar calls in different places, like you kind of see the same patterns, even if it's like method A calling well below method B and C, and then kind of the similar approach in another place, just with some other lines in the middle, but it looks like the same pattern. What I call, well, one-liners, we'll see what it's about, but you probably have seen them. I will show you a little bit later. Methods with multiple return statements. This is kind of a controversial one. Many developers use this, and you will even see it in many open source libraries and stuff. And I understand the reason behind it. This is probably more like a personal point of view on that. Large functions is where classes go to hide. I'll explain that when we get there. This is another, that one before, large functions is where classes go to hide, is a very well-known quote. I don't remember from who. I don't know if it's also from Uncle Bob. You can look it up. It kind of gives you a nice idea, because it's a really good rule. Like, you can use it in many places, not only functions and stuff. Methods with improvable parameters is actually related to the one below, above. You will see why. Like I mentioned before, the best place to detect code smells is when doing code reviews. Don't merge code if it goes against what is agreed in the code rules by the team. Again, it shouldn't be like Joseph believes that this code is bad, so he's just rejecting it because it's a personal point of view. No, it should be able to mention why. Hey, this is going against the, I don't know, MVC pattern. This is not really applying the observable pattern that we agree for all of our, collections or whatever. This is not thread safe. It should really focus about mentioning the technical stuff. If somebody believes that mentioning this is how I do it as the only reason, something is not good there. It should be more technical. Also, when you do these code reviews, don't just say, hey, this is not okay. Again, let's be more technical, more detailed. This is not okay, and I propose you kind of do this method, or reuse that other method that already exists. That is one of probably the best, or not the best, the shortest path to having a clean code is at least say, hey, do we have something already that does this? Let's use it. And if not, why do we have so many places with the same call and no method for that? What if that strategy changes and one day we want to do it differently? Performance issues can be troubleshoot using profilers. Well, this is just to mention about the previous topics. We talk about different reasons the code refactors happen, maintainability, security, performance. And this is not a talk about performance, but I just wanted to mention that, you want to really improve performance. There is a bunch of techniques, tools that help you. Some of them are called profilers and probably different concepts, but pretty much tell you which is the actual method or what is the bottleneck. Like this method is being called 3,000 times and it takes 4 seconds. So if you improve it there, and sometimes it's in the small methods, not in the big query that you thought it was happening, where these improvements can be done. So let's dive into it. Sorry if the screenshots are in Notepad. I just thought it will be, it will represent some approach that I do, is that sometimes when I'm doing refactor, for me, it's kind of a text approach. What I mean is that when you're not thinking about if it compiles or not, or a specific kind of, let's say, language even, you can see patterns and start moving things around in your favorite editor, but kind of away from the compiler ID or whatever. So if you expected black background on this, sorry for that. So this is an example of the typical Boolean parameters that you find, and you'll see this in many examples, including many Microsoft frameworks. Receive parameters that are Boolean. If you read between line 1 and 5, it's not very clear what the true and the false does. Like, well, they both create a menu item, but what about it? And then is when you go and see the, either the documentation of the API or your own code and say, oh, okay, line 7, I can see that create menu, receive a Boolean parameter that is, telling me if it's enabled or not. Should we display the item in gray and disable, or in black and enable? So that's one of the reasons, but it's not the only one. I'll show you why or how. So how do we refactor this? Well, we should, if you have an if else in a method, probably you need 2 methods, each one with its own single behavior, following the S in solid of single responsibility. Like a method should only do one thing. So if you see the code on the right, there is no if else in there. And it's very readable because it says create enable menu item on line 21. And it says create disable menu item. So your code is telling you what it's doing. And this is providing also like a look at what comes next. If you check for the, like in line 39, it says like font style. Like instead of just trying to have everything in ways of true, false, on a bunch of parameters, like, I don't know, font size and many things, we'll see this a little bit later. And you will see this in many APIs. They provide you kind of modifier in a single class. You just fill that modifier and you just pass it. In that way, you don't have to keep adding parameters when you need more modifiers, like bold, italic, underline for the text or whatever. What happens with Boolean parameters? Yes? Okay. So when Boolean parameters get out of control, like this example that is mentioned here, what does this line does? Like you'll find this is, I don't know, create menu item, true, false, false, true. Is like, okay, that's not very helpful. If you have to stick to using Boolean parameters, meaning that you're calling an API from someone else or whatever, or you just want to at least make it a little bit more readable, you should at least try this approach, like declaring a variable that is meaningful to read, and then just pass it. There was a time when I think still many developers think that I don't know, adding a variable and assign it, really is going to make your code really slow. It's not really that case, unless you do something really special in that declaration. This one, as you can tell, is from actual code. There are many things in here that can be improved, but before giving you the answer, I want you to, kind of just look at this and kind of think, like, if you see a pattern here, it's not very obvious at first. I want to give you guys some seconds in there. So, I have seen so many times people accessing the same property over and over. When I had the discussion back then, who will say, yeah, but this is fast, the compiler says this is just a value and accessing this is already in memory, blah, blah, blah. Yeah, all that is nice, but does it help to have it in 3 different places? And again, does it help to have this in 2 different places? Especially when there is nothing going to change what is returned. Like if what we had in line 4 changes because something happened in the database, and then what it happens in line 11 is different, then you should call it again because it's going to give you a different value. Let's see. Okay, so we have these rectangles in orange for this pattern, let's say, and these ones for the other pattern. And it's not really making my code more readable. So pretty much what we do is we use variables to store that. I mean, this is probably something you've done or not, you've seen or not in the past, might be obvious to you. But I want you guys to focus on how the code becomes more readable. For instance, in here, the onClick, it wasn't really sure about what this onClick was doing. This is what I call those one-liners. When your line starts to break in your editor, probably means you're doing way too many things in there, or your variable names can be maybe very long. It's not bad, but be careful about those one-liners because they're hard to read. So like I was saying, this onClick wasn't very clear of what it was doing. Now I can read here that this onClick is just kind of, formatting a string with 2 values. In here, encrypted record ID just became, encrypting the username using the record ID above. Also the same again here. So the code below and the code above doesn't look very much similar. And I hope the code below is more readable. Well, I got assigning method calls to return a well-named variable, like, record ID, encrypted record ID. It provides context and avoids having to make calls multiple times. It can be reused. This is kind of a very straight refactor. Probably so obvious that many people will not do it because they don't see the benefit from it. I see it. The code below is very understandable. Again, if your line is too long, maybe you're doing 2 things at the same time. Can this be improved further? For sure. Sometimes when you're doing refactors and you do a small refactor like this, when other patterns come, like, hey, I noticed that we're formatting, a string and 2 values, even they take the same 2 values. Maybe can we wrap it up that into a single method and just call it once? Maybe can we have a function for just like, preparing this information? Like this one should be, again, if we're following the single responsibility, a single method should be modifying W-link, another one for all link, and so forth and so forth. In many, many examples of CleanCode, you will see that methods that are longer than 5 lines is usually very weird. At least in the examples. I don't know, in the real life code, that's the case when they program, but I hope it is. Well, the one-liners. Also sometimes what I call, let's call nested calls, like the one in line 2. We call a method, which calls a method, we calls a method, and blah, 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 blah. And then, combined with this false, false, false stuff. So again, like, I would probably have to explain to you what this is doing, because it's not very readable. Lines 2 and line 6 in here. And so let's see how this is improved. Why nested calls is a bad practice, at least from my point of view. When method A has method B as a parameter, which again has method C, D, how do you handle exceptions in there? How are you going to provide a meaningful error besides that an error just happened? Each method is going to, I don't know, throw that. And then sometimes, like, if you will not see patterns of, like, usually can see this better vertically. Like if you just see, method A calling B and C, and if you start to see that somewhere else, it's easier to detect and say, hey, there is an opportunity to move this to a single place. When you do nested calls, it's kind of hard because the parameters are different. It's not hard to keep track of who's calling what in which parameter. So I rather have intermediate variables. Makes the code more debuggable also. When you have nested calls and you step into our method, it's going to be a nightmare to follow because you don't know inside which method you are. Then you start to step out and it's kind of very hard to follow. So what we did here is we created a method that is called add text menu item. Pretty much, although it's not visible here, and I just realized that what this is doing is adding, again, items to a menu, and like they were always called with false, 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 true, for instance. So again, instead of, like, for instance, if you see this item text, I keep that into a variable, then I just make the call. Other people could just, put the string format in here. Sure. If it's readable for the whole team and nobody cares about that, just keep it. I mean, there is not hard rules for that. And this method is providing context and meaning to what is happening. So if we are going to write this code again, it starts from here and it's like add text menu item. You see, it's very explicit. You just provide like the GCC menus, whatever, all the data that it needed, and that's it. Shorter line, easy to read. What the method says is what it's doing, and it's reused here. And it's keeping the flexibility because it's allowing you to have, you see that it's similar to a string format. It has these brackets, so it allows variable amount of string parameters in the template. So you could have 0, 1, 2, 3, 4, 5. I think I mentioned all that is happening here already. Yeah, well, so there are some reasons to have those single line statements with multiple nested methods. Many developers usually say it's more compact, it's faster than multiple statements in different lines. Well, I would like to see someone to prove that, or to send me the tests about calling method A followed by B followed by C instead of calling them all nested, and see which one behaves faster than the others. Like if you are that concerned with performance, use profilers and let them help you, or other tools. Okay, this one is a very simple example, but try to imagine a really long method. And then sometimes you're debugging, especially or whatever, and you think it's going to go into a place of code where you just added something, and it just boom returns, and it's like, what happened? There was a return in there above, you didn't see it. So it never reaches, where you were. And sometimes to get there, you have to open a form, fill it, send it, open another window. I don't know. Imagine a really long process. So it's going to be frustrating. It's going to be hard to keep track of the flow. Like when we read code, we should be able to follow it in our mind. If we're not, it's either because we are too tired or because the code is getting maybe too complex. It should be splitted or at least organized in a better way, like in smaller focus points about solving this problem, about only solving the next problem, and so forth. So this is like just a small example also from real life. Like these two returns, and this probably will pass 95% of code reviews, the lines from 1 to 6. But like at least if you're going to have that many things in common and the only thing changing is in orange, let's do it that way. Also, if we're going to apply what I explained as the first example, if we have an if in one of our methods, maybe we need two methods, one to return one summary and the other one to return the other. Like I say, even with my own examples, now I don't feel so comfortable because they could be better. And this is what CleanCode is all about. Without losing the focus of what you're doing in your task, without losing the scope of what you're trying to solve. Well, hard to follow when the method is long. Well, a single return, makes debugging really easy. You just put the breakpoint in there in a single place. Again, like I mentioned, you're going to see this pattern with many public repositories. But abusing of this is a code smell. Performance is not different to a simple if-else. And like I mentioned, which probably means that you need to separate that, one for the if and one for the other part, in two methods. Well, pretty much the idea in here, it is that you try kind of take a look at this. If you want to raise your hand or participate is fine. If you want to do it in your head, is fine too. The idea is that thinking about what we have just talked about, what the example that I have given you, how many code smells can you, how many opportunities to do things here can you find? I'm going to leave it there for a few seconds. When I did this in the other talk, it was nice to see how many things were mentioned that I didn't even realize. Like somebody mentioned nested ifs, and say, well, I had never heard of that, like a code smell, but it really is sure an indication, like things are getting, let's say, quite complex. I know that we come from a place that, like many years ago, it was normal to have, I don't know, similar to what we call a module today, almost inside a function or method. And here we have, three ifs nested in. Like, what? When is it return and rebuild? When exactly? If especially that single if without braces. That's not a code smell, but it's just something that always kind of triggers me. Like, why? So we have multiple returns here. We have probably doing many things in a single place. So we should have at least, like, I don't know, a variable that returns at the end at least, and try to simplify this. Also, like, what is that column as is parameter? What is it doing? I don't know, it's not very clear. Even renaming a variable, because it's considered a code refactor. Like, that else at the end, is it really needed? I don't know. For me, it's really hard to follow. It's probably just, I don't know. I got used to a single return. Large functions is where classes go to hide. And there is like many variations to this, because in reality, it's not only classes. Whenever you see code similar to this, there is possibility of refactor. It's up to you and the team to decide if it's the moment to do it or not, on the implications, things that could go wrong or that you need to test during these changes. What I mean is like nested loops, all these blocks of if else if at the beginning seem like they could be in a single method. Two methods, maybe, I don't know, maybe one for this if else, because pretty much all they're doing is building a strings depending on, for instance, the cell type, apparently, something like that. And it just makes the code more complex. And like, again, like for instance, this for each with a single line looks like, hey, this is perfect. This doesn't need to be refactored. Well, actually, I would have a method that says kind of like, I don't know, concatenate wraps or whatever this is doing. Because in that way, what we read is what the code is doing. Otherwise, if you have to like read it 3, 4, 5, 10 lines and then make sense of those, it's kind of like, could be nice to have them into a single method. I remember someone said to me, like, the moment something gets reused for the second time, or could be reused for the second time, put it in a method. And nowadays, I think if it makes the code clear, put it in a method. It doesn't matter if it's going to get reused or not. Hopefully you will eventually start thinking about, yes, I'm going to split it, but I'm going to split it in a way that it can be used later, of course. But it doesn't necessarily mean that if nobody else calls it, it's not worth having into a method. If it provides some kind of abstraction, which a method always does, because it's hiding the implementation details, use it. Make your code clear by wrapping things into methods. Please don't do what I have seen some people do, is like they will just put this and call it part 1 and wrap all these other parts and call it part 2. Hey, I just refactored that. No, you need meaningful names with meaningful results in each of those methods. Well, the idea behind this is to do a live refactor exercise. Well, we just did kind of in our heads. Let's see, which one is this? This is the one that I kind of mentioned at the beginning. Sometimes you have this kind of, even if it's an API or something else, or if it's your own code, whatever, you find this kind of thing like, hey, you want to create text, I don't know, imagine text editor or image editor allows you to add text, and you can define if it's bold, underline, italic, whatever, and then the font size in number, and then say, yeah, looks kind of good and not so good. Like, I already have Boolean parameters in there. It feels kind of like I have many parameters in the method. You say like 4 is not many, or 5 is not many. You will see what I mean. Oh, sorry. Let me go back to here, to this one. So large functions is not always where classes go to hide. What it means is that sometimes inside the logic, you see that, pretty much you're almost even declaring something, filling it with properties, and then using it, applying methods to that. And it's like, it feels like there is a class hiding in here. I don't know, the class, well, products is not a good example, because it's the typical example, everyone always creates a class or table products. But you can imagine, I don't know, invoice line could be, you're creating an invoice, and it seems like you're always doing the same thing about, I don't know, having the amount, the quantity, multiplying the quantity by the unit amount, then getting the subtotal. And then it's like, hey, maybe this is too long. So it's not always where the example that I provided here was for where methods go to hide, like we need more methods. But sometimes in this code, a pattern starts to emerge that is classes. But pretty much look out for complexity in your code. And it could be methods, it could be classes, it could be whole modules, it could be web services, depends on your approach and your architecture. So going back to this, pretty much we already noticed that like this is kind of getting out of control. Calling this is going to be like, again, true, true, false, false, true, true, whatever. It's not going to be very nice. So when you have like already enough parameters and there is a chance of that it's going to grow, like I'm going to provide eventually the color of the font style, then, well, let's have those parameters pretty much move inside a class. So you see that is bold, underline, italic, and size is now part of a class called font style. And then create text is receiving that. Some people could say, hey, you're pretty much doing the same. Yes and no. First of all, I'm purpose here. Let's say it's free. You don't need to add that everywhere. Imagine that there were more methods like this: create text, modify text, whatever, and all of them receive these parameters, this amount of parameters. If you add one, you will have to add it everywhere. So it's better to think about this as font style. And the most important thing that this is doing is the coupling the content of the text, the actual string, from the styling, like, which is perfect for what we're thinking about. We're doing a text editor, we're doing image editor. We need the user to be able to modify this style without modifying the string. Or we could just attach more things to it. Like we want, if we wanted to have other things besides font style, this text element can grow really fast because we could just add more lines here, more properties here with different classes. And then kind of there are properties that are set, some that are not, but they are kind of decoupled from the original element, let's say. So I call that methods with improvable parameters, because sometimes could be just the naming or just not using Boolean. I don't know how the actual books call that. So as you have seen from what we have done here, follow here through the exercises, is that we first find the candidates for a refactor, using code smells and code patterns as a guidance. Like, this should follow a really clear pattern. If it's not, how can we make it follow a pattern? We don't necessarily have to follow this code, only the patterns that are mentioned in books. Of course, teams can agree on their own patterns. Like here, this is a list of acceptable patterns, including ones that they probably name by themselves. Like, they found something to be useful because of the combination of libraries that they use, that they're going to apply that pattern. This is how it has to be done, otherwise it will not work, for instance. So this again should be agreed by the team. And you use those to see the code review, or when you're refactoring something that's already there, it was merged before, to say, hey, this is not following the same pattern. We should change it. Like I mentioned before, the idea is to check for the existence of unit tests for those methods that you're about to change. Before changing anything, run the tests, take note of the existing results. What I mean is that for some reason, which is usually time, people don't always keep up the tests with the classes or with the methods. So the first time you run the test, sometimes you don't get 100% results. Sometimes some tests fail. But if that is the initial test results, keep track of them. Write it down, take a screenshot, whatever. You're going to see how it becomes handy. Well, you apply the code improvement. How? Well, I just gave you some examples. There are plenty of them. And then here is where they become useful, is that run the test again and check to see that they return the same values. If not, well, go back to step 3, right? This is kind of similar to test-driven development. You know, in this case, you're refactoring code until it returns the same. Of course, not blindly, like you're changing anything anywhere, but using the typical logic you use to develop software. Sometimes after the refactoring, you find that code can be improved a little bit more. So we have to be careful about that because, like, we agree on we're going to make improvements only on this method, only on this module, and then these other changes in other places. So you have to be careful. Like if it's out of scope, you know, don't do it. Maybe keep a list of code improvement opportunities somewhere. But if it's part of the scope, well, go back to step 1 again. You know, find a candidate for refactor. You already kind of have it, you know, and you know, keep following that. But be careful about falling into the I ended up refactoring the whole project, and I started with a single method that had to be changed. The ones that are in yellow is the things that I mentioned at the beginning. Is like, if you don't have unit tests and you don't want to write them, try to have enough developer tests to cover the different scenarios. If this sounds like too much work, maybe unit testing is not a bad idea after all. If you feel like you're going to end up refactoring the whole code base, stop and try to apply the refactor that are related to your task only, or to the scope that was agreed. What I mentioned as the list of code improvement opportunities is pretty much that. It should be a centralized document that we as a team keep. Kind of say, hey, at least I raised my hand about that, and it's in there. Any other developer can see it. Maybe if they find it, they don't report it because it's kind of already there. And hopefully it will move from there to a task in the Scrum process or whatever process we follow. When does it happen? Well, it's up to you to decide how often do you check this list of code improvement opportunities and agree on converting one of them. Like sometimes there are 10, you only select one for the next sprint, and then fix it in there. So let's see some advices and conclusions. I almost never talk about conclusions. First of all, because this is a open subject, like many things were not covered here. Many ideas to provide you like the basics, like kind of getting you in that place where you say, I wonder which other code smells out there. Where else can I read more stuff? And conclusions, like for me, when it's only being done by one person, it's kind of hard to call them conclusions. Let's see. Like I have mentioned plenty of time, architectural decisions and code style to use should be agreed with the team. The main benefit of this is that the code base, if it's followed, it should look like uniform instead of what I usually find is, the reality of our world is that the code base becomes a patch of ways of doing things. Like you can go to a code and see, hey, this one was done by Maria. I know her coding style. Shouldn't be like that. Should be like, hey, this controller looks like it was written by one developer and it was written by 7. Let's say someone wants to introduce a new pattern, a new way of doing stuff. There should be a discussion of what to do with the previous code. Like, yes, we're going to start doing that from now on, but we don't touch anything from the past. That's the perfect recipe for having the above, a batch of things. Is refactoring what is in the back could be really long, could be really hard to test. But sometimes if you are really into CleanCode and the whole team accepts, and there are plenty of unit tests for that, It's not hard. You can even try to do a search replace if it's not such a complex refactor, to just run the unit tests. What if they passed or most of them pass and just a few changes are needed? Again, code review is not about I'm trying to merge these because this is the way I like it. This is the way it's better. And we should provide patterns or best practices of why we did that. Like, hey, Microsoft recommends that when using database connectors, we use the using or we use work of unit, or I don't know. There are so many patterns. Sorry. Comments in code are particularly useful if you are generating technical documentation, like I mentioned before. Sometimes people say, hey, just there shouldn't be no comments. Well, some tools just take what you put in the summary and generate really nice API documentation, whatever, for other developers, which could be really useful. It gets outdated really fast, of course, yes. But like for me, it's probably the only use for a comment. If it's not doing that and it's just there just to make your code better, well, change your code. Code should be read in a way that is better than comments. This is something that I read while I was looking for materials for this talk, is that legacy code maintenance is more about reading code than writing code. So why not make it more readable? Like if we're all spending more time reading than writing, let's make the reading more interesting. I don't mean to include like a Harry Potter section in there. I just mean to make it better. What are the advices? Even many of them for me. Read about code patterns, read about best practices. Try to read code at higher level than just syntax, which means practice pattern detection. Instead of just looking at, what this line of code is doing, kind of step out a little bit and see like the general flow. Sometimes you compare that to other methods, like these two are pretty much doing the same thing. The only thing that changes is, I don't know, the name of the file. So why don't we have a method that does that? It's not always that simple, but you get the idea that when you step out a little bit of your code and even start looking at how classes interact at higher level, even if you're not an architect, you're not a software designer as a role, I invite you to do this because it can really help you understand sometimes things that are affecting each other, but you don't know why. Well, kind of step out and see how things are interacting between each other. And sometimes a pattern emerges. It's like, I've seen this before and I know where. And I don't want to write the third one. I want to reuse what is already in there, make it work for what is already there, and then add my own. Yes, that's a lot of work. But it's beneficial because the next time something very similar comes in, or already is going to come in, you just need to call that with a different parameters or just add a few modifications, and it's going to make things faster for you. So don't be afraid of doing refactors if you believe it's going to save you time in the future, and you can prove it because there is the backlog of stuff. I know that some tasks are going to come into the sprint that will be affected by this, or should be implemented in here. So any change that we make here is going to make us faster or better in that. Pretty much, I think this summarizes what we have covered here, is that the idea is to leave code in a better shape that you found it. How is it better? What is better? Well, like again, there are code patterns, there are code smell, there are many things. Let's see, and just to wrap things up and maybe open up for some questions, comments. At the end, you will get this list of references. Like this is one that I kind of look for at the beginning. You can probably find many other ones, like why it's important to your business. Like usually when the client is not so willing to spend time or to pay developers for redoing stuff that is already there. And there are some reasons, some things to mention, but the one that I mentioned is good enough. Like, hey, it's going to take longer if we don't do it. Next time you quote this change, is probably going to be more expensive because a developer is going to take more time. More time? Why? Well, because it got more complex and nobody made it easier to maintain. The different type of code mails. This refactoring guru is a really nice site. It kind of has, let's see. It has a classification of different things, of different code smells. Yeah, large method, large class, and sometimes gives you a really, you know, an example. What is the benefit? It's really like a nice way. I thought about including some of them in here, but they already been nicely explained here, so it kind of doesn't make much sense. The one that I like, let me see if I can find it. It's called feature, let me see. Yeah, feature envy. You sometimes see this, like, you can imagine this line separating one class from another, whatever. And like you will see that class A, for instance, creates class B, and then it starts to do a bunch of stuff from B and try to interact with B, and it's always around about the other class. And it's like, maybe that method should be in the other class. Shouldn't be here. If you're doing that much about that other class, maybe you're kind of just jealous of being on the other side. So it's kind of like just move the logic where it belongs. Like it has really nice sections, like when not to pay attention to when this happens, or what is the benefit again, what is the treatment again, move the method to that place, or extract to a method. So you can see here different methods of that. Let's see. you guys are welcome. So I don't know, guys. I think we reached the end of the presentation. Well, I didn't read all of this slide. Give me 5 seconds. So pretty much, some books are going to be mentioned here. Somebody asked me later in the previous presentation, like, hey, do you have more to read? And I found this really nice list. Someone made a list of 18 best books about CleanCode. I found this one from Martin Fowler. It's also nice to read from one of the masters. And then there are many tools to help you with your code analysis. Some of them are like what is called static analysis. Like they can only read your folder, and from that, like you don't have to run them to run your code. So the tool works. Some are linked and depend. This one is, I usually just use the trial, kind of is a little bit expensive, but it really gives you an insight. It even calculates the technical depth for you. Yeah, it can be that precise and things that could be done better. It points out so many different stuff, like it will just give you a whole list. And it will mention, like, I don't know, this is called feature envy. Is like, it's happening in 18 places, you know, similar to the error list that you get when you compile. And depend kind of gives you complexity of the code. If you have unit tests, it will give you code coverage, really in detail, really nice tool. And there are plenty of more tools. This link in here contains like 20, 30. Probably while this presentation happened, more frameworks became available for that. Okay. You're welcome. So, guys, thank you, guys. Feel free to start me up, and hope to do a second one. Feel free to reach out for me in Slack, email, whatever you choose. If you have any questions right now, anything you would like to comment also by voice is fine, no problem.